All right, this is going to be objective 33. We are going to solve systems by substitution. Going back to last Thursday, we started solving systems by graphing. Can someone tell me what a system is? Because again, you get a certain type of equation on a test, you need to be like, this is this type, and this is how I'm going to solve it. You don't need to stare at it and go, I don't know. That ain't going to work. So how do you know you're looking at a system when you see a system? It's got more than one. So basically, you're looking at two equations together. Two linear equations is what we're going to be looking at. I know you've already written this definition down. Tomorrow, when we do systems by elimination, we're going to write the definition down again, because the more times I keep telling you what the definition is and what you're looking at, the more times you'll remember it. Okay? So again, a system is solving two or more linear equations at one time. And again, in Algebra 1, we're just going to look at two. So solving two at once. Any questions on that? Okay. Oops. Let's take it if I put my pen down. I know you've already looked at this. I'm just reviewing with you again. Okay. When you graph a linear equation, what does it look like? If it's linear, it looks like a line. You do realize that other equations, every time you add a degree, which means x to the first power is linear. Those will be lines. X to the second power, which we call quadratic equations. Anybody remember what those look like? We haven't looked at it. Anybody remember? Remember what quadratic equations look like? What shape? We know lines, and we also know those are called parabolas. Those are U's and N's. When you get into a cubic equation, which you won't hit in Algebra 1, but those make like a little up, down, and up. When you get into fourth degree, that's what I'm doing today in Algebra 2, those look like this. Okay, when you look at absolute value equation, everybody knows what an absolute value equation looks like, okay? Those look like V's. Every type of equation has a different shape. Do you understand that? Yes? So, you know, right now, the only thing you have to worry about in Algebra 1 are linear and quadratics. Quadratics we'll get to in about a week or so. And again, quadratics are U's and N's. Linears are lines. That's all you got to remember in Algebra 1. Okay, so if it's linear, you're going to have the first line. Where are all the solutions or answers to that line? On the line. They are the points. Remember this? We tried it the other day. We took a point, you plug the x in, you plug the y in. What happens to the two sides? They become equal or balanced, because that's what an equation does. It makes it equal. Okay? You can take any of those points and plug them in. So if you graph the second one, where are all the points to the red line? On the red line. So where's the points that hit the red line and the black line? Where they intersect. So what would happen if I took that x and that y and plugged it into the black line equation? It would be equal. Do you understand that? What would happen if I took that x and that y and plugged it into the red line? It would be equal. You need to remember, even though we're not going to do it graphically today, you need to remember that's what you're looking at, okay? And that's what you're trying to find, even though we're going to be doing it like solving and algebraically. That you are looking for an x and a y. What would it look like if it were no solution? They would be parallel, okay? And they wouldn't be touching. Any questions on that? What would it look like if it were many solutions? It would be a line on top of another line. Okay? Everybody okay with that? Just refreshing your memory. So either it's going to come out where it crosses in one place, it doesn't cross at all, or it crosses in lots of places because it's on top of each other. Okay? All right. What I would like to do, let's refresh your memory on how to put these in the calculator. Okay? We're going to solve it in the calculator first by graphing. Okay? If you will, can I talk you through this, or do I need to get my calculator up and show you? You okay? If I talk you through this? All right. So I want you to go to y equals. Can you put both of those in the calculator? As is? Got your calculator? Everybody got the calculator? Okay. Put in y equals 2x minus 3. And then put in y equals x minus 1 and hit graph. And I'll wait for everybody to get there. Let me know if you have troubles getting it in there and I'll help you. Okay, I'll get it. Just a second. Okay, everybody got it in? All right, now we see where it intersects, but we don't know. It's hard to know exactly how many over and how many up. So the calculator will actually tell it. Does anybody remember where to go? Jimmy? Second calc or second trace. It's right beside of the graph button. So everybody press that. Hang on just a second. Second calc. And then what choice do we want? You want intersection or intersect, choice 5, and you'll press enter, 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 enter. It'll have to go through first curve, second curve, guess, and then it gives you your intersection. Okay, what's the answer?
X equals 2y.
So the answer is 2y. Okay, so does everybody remember how to put it in their calculator? Your worksheet today is going to say graph each system by substitution and by graphing, which means I want you to solve it algebraically by substitution, and then I want you to go back and check it by putting it in your calculator. The more times you put it in your calculator, the more times you will remember what buttons to push. Okay? And as we get close to the end, I'm going to start showing you lots of tricks in the calculator, so you need to get handy with it and make sure you know. Okay? Any questions on putting it in the calculator? Everybody okay? Okay. Now what I want to do is I want to do what we do. Let's say you don't have your calculator with you. Okay? Let's say we want to solve it. I once had a student who lost his calculator and never found it the entire year. And you know me, I didn't give him one until he gave me my $100. So how did he take the test on this? He solved it by hand. And here's how you're going to do it by hand. Okay? So you need to understand the concept of substitute. If I have a substitute, what happens? What do you do with me? You take me out and you put someone of somewhat equal value. I mean, can't be equal to me, of course, but somewhat equal value to take my place, right? Yes, and conduct the class for the day. Yes, okay. Mr. Petway did a great job of that, I'm sure. All right. So what we're going to do, as long as you have one equation solved for y or x, it don't matter which one. Do we have a y equals up here? Yes. It doesn't matter which one. I'm just going to take the top one. What is y equal to? 2x minus 3. They are equal. They don't look alike, but they are equal. Do you understand? You know what it kind of reminds me of? 4 quarters and $1. Have you ever thought about that? 4 pieces of little metal equal to a paper dollar. They do not look alike at all, right? Agreed? But they are interchangeable. How many of us have ever asked for $1 for 4 quarters or 4 quarters for $1? Yes, we have interchanged them. So, what I can do is I can go down here. This y, I can take this y and throw it out the window. And in its place, I can put in the 2x minus 3 because they are equal. Does that make sense? So I'm going to take what y is equal to down in the second equation. I'm going to take the y out, and in its place, I'm going to put in 2x minus 3. Does that make sense? So I have the exact same equation, except instead of the y, I put in 2x minus 3. I just exchanged them out. Do you understand? Now, I have everything in terms of x. And you agree up here, because I have x's and y's, I can't solve for 2 at one time, right? But down here, can I solve for x? Because it's all one variable, right? Yeah. So let's review how to solve an equation. Ready? Here's our 5 steps. Parentheses. No. Fractions. Combine like terms on the separate sides. No. Let's put our variables on one side and our numbers on the other. It don't matter, pens and pencils. Y'all remember my trick? It doesn't matter what you move. What would I move? I'd move the smallest variable. So when I move this over, what happens to it? We subtract x. So 2x minus x is 2x minus 1x is 1x or x. And now what do I need to move? The negative 3 over and add 3. So what is x? 2. Oh, x is 2. We figured it out. Okay. Am I finished? No, because we want x and y. We want the whole point. So can somebody tell me, if I know that x is 2, what can I do with 2 to figure out y? Couldn't I take this and plug it in here and solve for y? Or couldn't I plug it in here? So here is my Vanna. I always wanted to be a Barker's Beauty. Y'all know what a Barker's Beauty is? Do they call them Carrie's Beauty, Drew Carey's Beauties now? Y'all ever seen Price is Right? And the ladies that they show all the stuff. You're going to get this. No, y'all don't ever do. Y'all are deprived children. So you can plug it into door number 1, or you can plug it into door number 2. Either one's going to give you the same answer because it's the same point. So which door do you like? 2. That's what I heard. It's fine. So y equals x minus 1. So I'm going to plug in 2 for x. What is y? 1. Didn't we get the same thing as we did in the calculator? Just another way to do it by hand. Okay? We will. Not yet, though. Okay? All right, here we go. All right, so we're going to solve this by substitution. If I wanted to put this in the calculator, what would I have to do to put it in the calculator?
Make it into
Make both of them into y equals? The top one's already in y equals. I would have to rearrange the bottom one into y equals. Does that make sense? But we're not going to do that right now. I want to solve this by substitution. Do I need both of them solved for y equals? We're so used to solving everything for y equals, but in substitution, how many have to be solved to substitute? I only have to solve one of them. So do I have one of them solved?
Yes.
Yes. Which one? The top one. So wherever I see a y, what can I plug in? The 2x. They are equal. So I can come down here to the second equation, and I can take this y, you know what I can do? Ball it up and throw it out. And in its place, I'm going to plug in the 2x. So we will have 7x minus 2x equals 15. And we can solve. What will I do? Combine like terms. 7x minus 2x is 5x. And then all I need to do is divide by 5. So x is what? 3. Am I finished? No, because we want a point. Okay, you want an x and a y. So what can I do with 3? You can plug it in. You can plug it into door number 1, or you can plug it into door number 2. Which one you want? 1. Either one will give you the same answer. So 2 times 3, so y is equal to 6. So what's the point? 3 comma 6. Any questions on that? Okay, let's do another one. Okay. Okay. Do I have an equation solved for x equals or y equals? I have x equals. Oh, do I need to rearrange that into y equals? Or can I plug in for x as easily as I can plug in for y? Does it matter which one you solve first? No. So as long as you have one equation that's either in x equals or y equals, you can plug in. So wherever I see an x, I can plug in what? What's x equal to? 1/2 y plus 2. Again, they don't look alike, but they are interchangeable. 4/4 and $1. They don't look alike, but they're the same thing. So, wherever I see an x in the top equation, I can take the x out. And in its place, I can plug in 1/2 y plus 2. So, Levi, what would my equation say? 1/2 y plus 2. The x, what did I do with this x? I threw it out. So what comes, we plugged this in, 1/2 y plus 2, in for that, then what comes after that? Minus y equals what? And see, I'm going to start calling on you to set it up, because that's the hardest part. If you can get it plugged in correctly and set it up, anybody can solve that. Well, not anybody, but I'm hoping you can solve that. That's the easy part. Okay, it's getting it set up correctly that's most difficult. So, what would I do? Parentheses. No, fractions. What would I do? I would take the whole thing and times by 2, the denominator. Multiply by the denominator. So what happens when you multiply that by the 2? The 2's cancel and you get 1y or y. Then 2 times 2? 4. Then 2 times negative y? Negative 2y. And then 2 times 1? 2. Make sure you times it to every single term. Everybody understand that? Okay, step 3, combine like terms. Yeah, what can I combine? Y and negative 2y gives me what? Negative y. Be cautious, careful, and conscientious with your signs. Then what? Bring the 4 over and subtract 4. So negative y equals negative 2. Then what? You can divide by negative 1 on both sides. Or what could you do? Switch sign on one side, switch the sign on the other. Am I finished? No. So, what can I do to figure out x? Now, be very careful. What do we normally plug in for? I mean, what? Well, we normally plug in for x. Do you see what I'm saying? That people would get confused and accidentally plug in for x, but this is y. So this 2 has to go in for either the y there or the y here. Now, how many of you would choose door 1? Can I show you how door 2 is easy? Door 1, you'd have to plug this in, then you'd have to move this over, which is not that difficult. But door 2 is just as easy. Don't let that fraction scare you. Check this out. 1/2 times 2 plus 2. What happens? Cancel and gives me what? 1 plus 2, which is 3. Okay, so what's the point? Is the point 2, 3 or 3, 2? Why? Just be careful. Make sure. I have a lot of students. Cautious, careful, conscientious. I have a lot of students. Number 1, you accidentally plug in for x instead of y. Number 2, if you get it plugged in correctly, do you see why people would say 2, 3? Yeah. Okay, make sure you get the x first, 3, 2. So, just be very cautious with that. What can I do to check this? There's a couple ways to check this. Calculator. What would I have to do to these? Rearrange them into y equals. Okay. And then what else could I do? What else could I take 3 and 2 and put the 3 in for the x and the 2 in for the y and check to make sure that the 2 sides are equal? Would I check just one or would I check both? Be very careful. Okay. If you check one, you better make sure that it works for both, because what if it works for that one line? Because remember, there's other points, right? But there's only one point that works for that line and that line. So make sure you check both. Okay. All right. What's different about this one? I do not have an x equals or a y equals. In order to substitute, you must have an x equals or a y equals. Now, does it matter which x or which y you solve for?
No.
Do I have a preference? I do. There's one up there that's the best choice, and that will be easy. Everybody agree if your problem has tons of fractions in it, it gets complicated, you get lost, and then you quit? Yep. Okay. There's one up there that's going to be real easy. Can someone tell me which one that is? Taylor, what do you think? The bottom one for what? So which would you solve for? The x or for the y? Why? Why? I agree. Tommy, explain why. If you would not have to divide anything by y if you solved for this. Everybody see that this is the only one that is pretty much by itself. This has a coefficient, that has a coefficient, that has a coefficient. Don't write this down. Let me just show you something. If you solved for one of these up here, you know what would happen? Let's just say you solved for that. You'd move this over, and you get this, and then what would happen? You'd have to divide by 3. And then what would happen? You would have fractions. Okay, you with me? And that's not a big deal to have fractions. You can work with fractions, but everybody agree it's harder when you have fractions. Yes. So pay attention. Always make your math easy. Look at your problem. I agree with Taylor and with Tommy. This one, all you got to do is take this over, and you get y equals 6x minus 7. Okay? I do caution you when you're solving stuff, make sure you pay attention to your signs and what you're left with, like especially if you're left with a negative y. Make sure you bring down the negatives and stuff like that. A lot of the stuff I graded last night, I saw a lot of little carelessness. Again, I'm not worried about it because you did much better on your tests. You know, your tests were really good after I made you aware of your carelessness, but just a couple little things. You know, people forget to change signs when you took stuff over. People forgot to bring down negatives. People added where they should have subtracted. Okay, little things. Okay? All right. Wherever I see a y, what can I plug in? 6x minus 7. Now, do I plug it into the door number 1 or do I plug it into door number 2? It's very important. What do you know about number 2 and 3? They are the same. You can't plug this equation into itself. You'll be like a dog chasing your tail. Do you know what a dog chasing its tail looks like? Where does it get? Nowhere. Does it ever get its tail?
No.
Not really. Maybe once in a blue moon you might see it get its tail for a second, then it yelps. Okay, but what's going to happen if you plug this into this? Everything's just going to cancel, like everything. It's just going to and you're not going to get anywhere, okay? You must plug this into the other equation. Now, when I plug this in, everybody agree it's going to go in for that y? Okay? Do I plug it in like this? What's wrong with the way I plugged it in? It says 36. What should I do? Always plug in using parentheses. Do you understand 3y plus 2x equals 4? So I just plugged that in for the y, and make sure you put parentheses around it. Because then what will I do to solve? What will be my first step to solve? What do I mean by parentheses? I'm going to distribute 3 times 6x, 18x, 3 times negative 7, negative 21. Fractions?
No.
Combine like terms. Yes, 18x and 2x gives me 20x minus 21 equals 4. When I move the negative 21 over and add 21, 20x equals 25. And when I divide by 20, x equals 5 over 4. Always simplify. Caught some people not simplifying on their worksheets and stuff. Is it okay to have fraction?
Yeah.
Yeah, it's fine. It's fine. Am I done? No. I got to plug back in. Now, how many choices do I have to plug back into? 3. I see 2. Show of hands, 2 or 3. What do you think? Put your hands in the air, 2 or 3. How many choices do I have? What do you think, AJ? What do you mean 3? We've got original door number 1. You put your hands down now. Original door number 1, or original door number 2, or new and improved and already solved for Y door number 3. And it's okay to use this door because this door is the same as this door, just in a different form. So which door would I pick? Y, because it's already solved for Y. If you plugged this in to either here or here, do you see what you'd have to do? You'd have to times, then you'd have to move it over, then you'd have to divide. You with me? This one, you can do this whole thing in the calculator. I'll show you. Watch. 6. I want you to put in your calculator 6 parentheses 5 divided by 4 close parentheses minus 7. Enter. And then math, enter. Y equals what? 1/2. Do you see how that was a lot easier? You didn't have to solve and move over and divide and this and that. You just plugged in, put it all in the calculator. There it is. Shazam. Okay, so what's my point? 5/4, comma, 1/2. Okay, what would your calculator give you if you like solved for Y and did second calc, intersect, enter? What would the calculator give you? It won't give you the fraction. It'll give you a decimal. So it'll give you 1.25 and it'll give you a comma. It'll say X is 1.25 and then it'll say Y is 0.5. So how would you get to the fraction? Just put in 0.5 math, enter, or 1.25 math, enter. You with me? Calculator will give it to you. Just give it to you in decimal form. Okay? All right. I'd like for you to try this one by yourself. I'll get you started. What would be your first step? You need to make sure one of them is solved for either X equals or Y equals. Which one would we solve for? The top one for which variable? For Y, because it's the one that's by itself. So solve the top one for Y and then substitute in and see what you... If you're not, everybody was getting it. What is the correct answer? Bradley? What would I rather have then instead of 1 3/4? 7/4, which same thing as 1 3/4, but 7/4, comma, 5/2. Yeah, 5/2. Yeah, very good. How many got 7/4 and 5/2? Or at least got part of it. Did you get the 7/4? Yes, maybe. Okay, first things first, you have got to solve for Y. So I'm going to pick, I'm going to pick this one, and I'm going to move this over and get Y equals 2x minus 1. Okay, and I still have people throwing the negative 2x at the end. Now that we know mx plus b, go ahead and get it in the right order, right? The x goes first, and then you just take that negative 1 and scoot it over. Okay, so wherever I see a y, what can I plug in? 2x minus 1, and so I can come into the second equation. What would happen if I plugged it in up top? Everything would cancel. And again, you'd be like a dog chasing your tail. You're not going to get anywhere if everything cancels. So make sure it gets into the other equation. So 4x plus 2, take the y, throw it out, but in its place, put in 2x minus 1 equals 12. Okay? Then I'm going to distribute 4x plus 2 times 2x is 4x. 2 times negative 1 is negative 2. Combine like terms. And I'm just going through this quickly because you should already know how to do this, right? Maybe. I hope. Did I lose you? And if I reduce that, you get 7/4. Okay? Any questions on that? Then you take this and plug it back in. If you know one of the variables, plug it in, you can find the other variable. Okay? Remember when we did x and y intercepts, what variable did we know? We knew that to find an x and a y intercept, you had to plug in 0 for one, and you could solve for the other, right? And it would show you where it was on the x and y axis. So if you know one of the variables, all you got to do is plug it in, and you can solve for the other. You can plug it into door number 1, you can plug it into door number 2, or you can plug it into new and improved and already solved for y, door number 3, which is the same thing as number 2, but number 3 is better because it's already solved for y. Whew. You got my point? Huh? You didn't understand that? Are y'all kidding? Are you serious? I said it too fast. It's already solved for y, and it's better than the other two because all you got to do is plug it in and multiply and subtract, and you can do it all in your calculator. Is that slower? So 2 parentheses 7 divided by 4 close parentheses minus 1 math enter y equals 5/2. And I would rather have, instead of the decimal, instead of the mixed number, and if you put 1 3/4, I'll count it, it's fine, but I'd rather have 7/4 and 5/2. That's what you will see on your SOL. Okay? You okay? All right, one more. You try that one. Yep. And that's fine. I've had people do that before. You solve them both for y and set them equal to each other. It's fine. As long as it's a mathematically correct way, that's okay to do it. Okay? Bennett just asked, he said, I think I just did that last problem differently. He took both of them and solved them for y equals both of them. And then he took each one of them, if they're both equal to y, he took both of them and set them equal to each other and solved. Could you do that? Yeah, you can. Like this one, are they both solved for y?
Yep.
Yeah. So if both of these are equal to the same thing, what do you know about both of these? They must be equal to each other. So try it, see what you get. What are you doing? Okay, no, there's already solved for y. Okay? And the second one's already solved for y. So write both of them down. So, remember, circle 1. What's y equal to at the top? So circle it, like I did. Okay, so wherever I see a y in the bottom one, now point to where you're going to plug all this in. Now, rewrite it, take this out, and plug this in for that. I think that will help you if you'll circle it and like point to where you're plugging it into. You'd be like Babe Ruth, pointing to where that ball is going to go. You know, you're going to point where your equation's going to go. All right, what is y equal to? In the top one, and I just picked the top one. Could you do the bottom one? Yeah, because they're both solved for y. So you can plug that right in there. And again, I encourage you, how many of you are having a little trouble setting it up? Because that's the issue. Okay, just a couple. I encourage you to do this. If you have one that's either x equals or y equals, go ahead and say y is equal to this. So I can come down here to the second one and point. I'm going to take this out and put all that in its place. And I think that will help you. Okay? Are you okay with how I did that, AJ? Okay. From there, use your rules. Parentheses, fractions. Combine like terms. No. Put your variables on one side, numbers on the other. What would I move? I'd move the negative 3x because when I move a negative, it becomes a positive. Okay? 2x and 3x gives me 5x. Then I would move this over and subtract 2, so 5x equals 2. And when I divide by 5, x is equal to 2/5. How many got that far? Okay? From there, how do I figure out what y is? How many doors do I have to choose from this time? I only have 2 this time. Door number 1, door number 2. I would say either one is equally easy because they're both solved for y. So let's pick door number 1. Is that okay? Y is equal to 2 times 2/5 plus 2. And again, you can put this all in your calculator too. Parentheses. 2 divided by 5, close parentheses, plus 2, math, enter, enter. What do we get? 14 over 5. So your answer is 2/5, comma, 14 over 5. Are you okay? Yes. Wes, you got questions? At all? Okay, hang on. Okay, did you solve it like I solved it? So what did you do? Did you get it set up? Like this. Okay, so how about I come to both of your papers? Is everybody else okay? And I'll look at it and see. It's probably something very simple. Were you getting the other problems I did? Yes, okay. How about we do this? That was my last example on this.